My name is Jefferson Kenney. I'm the design and product specialist for the ventilation portion of Unified Brands that typically handles the Avtec side of things. Today I'm going to run through some common definitions and terms and design capabilities for commercial kitchen ventilation. You'll also be able to catch some of this in a blog that we did back in March that was decoding the crazy jargon of commercial kitchen ventilation. Go to the news and insights tab of www.unifiedbrands.net. Either click on Avtec or March, you'll be able to find that pretty easily. And I help break down in there what these terms mean and how they're used. So the ones that come up the most, we'll talk about right now real quick. CFM, everybody says that they have a CFM number. That's the amount of air that you're moving. It's a cubic foot that gets moved every minute, cubic foot per minute. Much like an RPM, you don't pluralize that. So you can tell the difference with somebody that's a little bit more savvy in the industry. They won't say CFMs. You remember that one. That's the same with FPM. That's feet per minute. That's a measure of velocity. So CFM is your quantity. That's how much air you're moving. And FPM is your velocity of how fast that air is moving when it goes from place to place. A type 1 hood or class 1 hood, those are for grease producing equipment. Fryers, broilers, ranges and the like, braising pans, kettles. Type 2 or class 2, that's a hood that's designed to be used over a dish machine. And some localities will allow you to use that over light duty cooking equipment, maybe like a speed oven or panini grill, something like that. Collars are what connect the ductwork in the building to the hood. The ductwork will run from the hood to the outside to where the fan is located. The collar is where that connection is made. That's whether it's on the exhaust side or the supply side. All right, so IMC is the International Mechanical Code. That's pretty much where all of the codes that are used for kitchen ventilation come from in the US. Some of the locales will take entire sections or all of the International Mechanical Code and adopt it and call it their own. Ohio, for example, has their own Ohio Mechanical Code. It's almost word for word taken from the International Mechanical Code, and they put their name on it. The next is UL, that's the Underwriters Laboratories. They're the ones that develop the testing standards to say that equipment is as good as it needs to be in order to be safe and meet code. So if you get an extension cord from the store, it'll have a little UL tag on it, and that's to say that your 15 amp extension cord has been tested with at 15 amp. It is safe to use. It's not going to break if you bend it. That kind of electrical load is safe. You use the same kind of process with hoods, whether that's part of the construction method of a hood or for capacities. They have UL standard 710 is the category that hoods fall under, and everybody is tested to that same standard. ETL is Edison Testing Laboratories, and they're a company a lot like UL, but instead of making the standards, they do testing only. So if you can have a ETL listed component or a UL listed component, they should be exactly the same kind of quality. They're tested at the same standards. It's just a different company that actually does that test. So what is a hood? The hood is that big stainless box up in the sky over top of the cooking equipment. You can see our good-looking Chef Steve there underneath this one, cooking on a grill and braising pan. You have a hood in the kitchen to remove what needs to be removed from the cooking process. So that is heat, primarily, steam, flue gases. Flue gas is one of the ones that will come up as carbon monoxide. Obviously, that needs to be taken out. But they're also there to be a fire barrier between the kitchen and the rest of the building. So as all of the air moves out through the hood, you're straining the grease out of the air so that it's not in the ductwork, and you keep it in the hood. You might, think it makes sense to take the heat out because you don't want it to be, if you can't stand the heat, take it out of the kitchen. But what about the grease? Why do you want to keep that there? It's because grease is highly flammable and it's also very sticky. Hoods and the filters for hoods are designed to be removed easily without the use of tools, so that they can be either soaked or run through a dish machine, have the grease cup washed out, and that way you can take the grease, put it in the garbage, run it through a grease trap the way that you should. When it gets up into the ductwork, that's when it can be a little bit more of a problem. Because if the fire starts, if a fire happens and there is essentially grease stuck from the hood all the way up to the fan, there's a chance for the fire to run all the way from the hood up to the fan. So the hood is in there to make sure that the grease doesn't go into the ductwork. And the picture here shows a before and after, ductwork before it was cleaned, after it was cleaned. And that's because grease is so sticky and so flammable that you want to make sure that you catch it down in the kitchen. Some people will say some of the things that you look at, it feels like I'm cleaning my hood too often. That's actually a good thing, and it means that they're working better than what they're used to, because that way you're not letting the grease go into the ductwork. It doesn't create a fire hazard. It isn't on the roof or on the cars in your parking lot. So how does a hood work? What do you do? I think the easiest way to explain this is to think of an upside down bathtub. If you have a bathtub, the drain has to be able to pull water out at least as quickly as the tap is putting water in. Otherwise, you end up with a flood, as you see here. So if your bathtub is sized properly, the water goes out, you don't flood the floor. The same thing happens with the hood. If the hood is sized properly, all of the heat and grease and smoke and steam that's created through the cooking process is caught in the hood and taken out and doesn't leak out into the space. That stops a number of different things. It stops fire hazards, but also keeps the sights and smells of a kitchen in the kitchen and doesn't allow them to go into the dining area. That's kind of where we say there's a difference between odor and aroma. Aroma in the dining area is great when the food comes out fresh. The odor that can come from a kitchen, you want to make sure you keep in a kitchen. So that's our quick breakdown, Ventilation 101. Appreciate your time. Should you have any other questions, please reach out to me, or you can look at www.unifiedbrands.net. Thank you very much.